There's one exception to the power rule, so we're going to talk about it because it presents a few hairy issues here. 1 over x is the derivative of some function, right? And if I wanted to apply the power rule, then I would have to convert that to be x to the minus 1. So if I followed the rule blindly, this is what I would do. I would add 1 to the exponent, which is going to be x to the 0, and I have to divide by 0. But we know that that's a huge no-no. Okay, so that doesn't work. This is the one power function that we can't use the power rule backwards on. So what do? Well, we got to recognize that, hey, this is the derivative of ln x. So f of x would have to be the natural log of x plus a constant, right? Well, not quite, because here's the problem. I could plug negative numbers into f prime to get out answers, right? I could plug in a -3 or a -7 or a -1000 and get out a slope. But if I look at this f function, I'm not allowed to plug in negative numbers. That's an issue, right? Because there are slopes for some function that are going to come out, but there's going to be no y values that come out of this function. And the way around that is to do this, put absolute value bars around the input, and just to convince you that this actually does work, okay, this becomes a piecewise function if you want to remove the bars. It's equal to the natural log of x if x is positive, because the bars don't do anything if x is positive, and it's equal to the natural log of the opposite of x if x is negative, because the bars are going to make whatever's in here positive if it's a negative number. Okay, so what are the derivatives then of those two pieces? They better be the same thing, right? They better be both 1 over x. Well, we know the first part's 1 over x. We've been doing that all fall. What about the second part? Chain rule says first do the inside outer function's derivative, which is 1 over -x, times the derivative of the inner function, which would be -1. And you notice that the negative ones cancel out. Boom and boom. And so we get the same derivative regardless of what x ends up being. So this is a little thing to remember going forward, but it's important because if you try to plug in negative numbers without those bars, you're in trouble.